example number 8. Now, this one, we need to start this example by doing something that we've done several times at this point, and that's separating the denominator across the numerators. So I'm going to take the first numerator over this denominator, and then I'm going to add, oops, forgot my dx, always do that, my second numerator across my denominator. And these are going to be dealt with differently. So let's look at this right now and talk about techniques. Let's look at the one on the right first. So this one, there is only a constant up top. So because there's only a constant up here, my first instinct would be this is an inverse trig, because I can move that 4 out, do something squared, and this looks like it's going to be an arc sine. This one, because it has this variable up here, my first instinct is not an inverse trig. However, I can see if I make this u, the derivative of that would be negative 2x. Well, I could add a negative 2 to that, and there's my derivative. So, this, my instinct would be a u substitution. So I want you to pause the video and try that part out. Let me get you started. So on this first part, you're going to try to make u is 4 minus x squared and go u substitution out for this one. For this second one, you're going to move the 4 outside and then separate these as 2 squared and x squared and do an arc sine with that one. So pause the video and try that out, and then come back and see how you did. Let's check what you got. So for my u substitution 1, du is negative 2x dx, so I added a negative 2 and a negative 1/2 to keep it balanced. So that is my du. So when I put it all in, this is what I should get, 1 over square root of u du, which is u to the negative 1/2. So I take the integral and get u to the 1/2 over 1/2. Flip that to be 2 over 1, and those cancel each other out, so I just get a negative u to the 1/2, and then I just plugged my u back in. So that's my first one. Here's my second one. I took my 4 out, and then this is now 2 squared and x squared. Because that x is by itself, I don't have to think any type of u substitution. So I leave that be, and this, because there's a square root and a, oops, that should be a subtraction sign, and a subtraction, this is going to be arc sine. So arc sine of a over, or sorry, of u over a. So x is my u, 2 is my a. And that's all we need for that one. And then my plus c at the end. So that should be it for number 8. We're actually going to skip forward a little bit and do number 10. Because number 10 is very similar to what we just did, where we're going to start by splitting this up, and then it's going to be a minus because it's subtraction. And then, of course, I need my dx's. And then same thing. This is going to turn into an inverse trig because there's a number on top, and 99% of the time, that's how we know. This one can't do an inverse trig because we have that x. However, if I look at the derivative of this, it's going to be negative 2x, which means I can add a negative 2 to that, and that's the du. So this is going to be a u substitution. So what I want you to do is follow your notes from the last problem, pause the video, and try and do this one, which is very, very similar. Ready, set, go. Let's check what you got with what I got. Now, I did skip a couple steps in between because this one is so similar to the last one we did. So right here, I took my 3 out, and I separated those as 1 squared and x squared. Same thing. Here, for my u substitution, I had 1 minus x squared, so I got negative 2x dx. So I added a negative 2 and a negative 1/2 to balance. So there's my du, there's my u. So I get a positive 1/2 because of those two negatives. 1 over square root of u du. Now I know this is going to be u to the negative 1/2, so when I take the integral, it's u to the positive 1/2 over 1/2. And now I flip that 2, and it's going to cancel, so that's where I get this 1. And the u to the 1/2 is the square root of u, and that is my u. Over here for the arc sign, I use my u over a. That one's my u, that one's my a, and that's what I get for that one. So that is all for this video. In the last video, we're just going to do a couple more examples of some last integration techniques.